because 2 to the 0 is 1, minus 4. 3 times 1 is 3, and I'm going to subtract 4 from that, which gives me -1. So this tells me that my x value that I subbed in was 0, and the corresponding y value is -1. So that would be my y-intercept. And I'm going to plot that on my graph. 0, -1. I'm going to highlight it so we know that that's the y-intercept. We're done. What questions do you guys have on the y-intercept? Now the horizontal asymptote, remember, is defined by this value that we add or subtract from the exponential part. And we say that the horizontal asymptote is always y equals something. In this case, it's -4. So y equals -4 is my horizontal asymptote. So I'm going to find -4 on my y-axis. 1, 2, 3, 4. And I'm going to draw in a pink line for my horizontal asymptote right there. Okay, so that's my horizontal asymptote. So now our x-intercept, we let y equals 0. So I'm going to have 0 equals 3 times 2 to the x minus 4. Now you might be like, I have no clue how to solve that for x. And that's totally fine. If you guys were in honors, I would probably teach you how to solve this using a logarithm. But for now, we're just going to use decimals. So you just are going to take one side of that equation, so y equals 0. And we're going to set it equal to 3 times 2 to the x power minus 4. We're going to find the intersection between those two graphs. So I'm going to scroll. This is equals y. Let me zoom, in, because right now we are way out there from the warm-up. Maybe if I zoom out, it'll be easier to get to where I want to go. And then zoom in. Here we are. So we're looking for the intersection of our blue and red functions, which is going to be right there. So I'm going to just put my dot right there on it. And this tells me my x value is 0.4. I'm going to round to 2, 0. Okay, and we just used Desmos to solve that. Then I'm going to fill in my table of values. Oh, I should probably plot that. So 0.4 is kind of close to a half. So it's going to be somewhere right there. Okay, my x-intercept. Okay, and then I'm going to do kind of values around my y-axis again. So I'm going to do -2, -1, 1, and 2. And I'm just putting these values into my calculator. I stick -2 right in for x. So I guess I'll show you how to do it. Let me make this bigger. You can also do it in Desmos. Okay, so let me get rid of that. And I'm just taking 3, multiplying by 2, raising it to the -2 power. I should put parentheses around there just in case. And then subtracting 4, and I should get -3.25. All right, then I can do the same thing with the 1. So 3 times 2 to the -1 power minus 4, -2.5. And this next one is to the first power. You should get 2. And then when I sub in the 2, oops, well, fine. I should get 8. Okay, so I can plot these points on my graph. I have -2, -3.25, so 1, 2, 3 and a quarter. -1 and -2.5. +1 and 2. And +2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, what questions do you guys have on that problem? Okay, if there are no questions, I'm going to fill out this last one really fast. Okay, so don't feel bad if you feel like you're not keeping up. I've posted the solutions already, so you can go back and look at them. So we're going to do our y-intercept first. We're letting x be 0. So y equals 2 to the, I'm sorry, oops, where's my whiteout? To the 0 plus 2. Okay, and then we're adding 1. 0 plus 2 is 2. 2 squared is 4. So 4 plus 1, which is 5. So my y-intercept should be at 0, 5. Right? Our horizontal asymptote is y equals 1. Because I added that 1 to the end of it. I can draw my horizontal asymptote in here. Right? And 0, 5, 1, 2, 3, 4, 5. That is my y-intercept. Right there. Oh, man, you guys can't see. Y'all should have let me know. All right. We should have no x-intercept because our function is above this pink line. It can never go below it. Okay, so it's because of this horizontal asymptote. And for our table of values, we're going to have -3, -2, -1, and 1. And so we should have 1.5, 2, 3, and 9. Okay, so 1, 9 is going to be right here. -1, 1, 2, 3 is right here. -2, 2. And -3, 1.5. So we should have a graph that kind of looks like this. Okay. Whew, so I know that I'm going so fast. You know what? I think we might end up, I don't know, we might end up having to extend this lesson to 2 lessons because I really wanted to go through some of the around the world with you. So we'll see. Let's see how far we get with the decay functions. What questions do you guys have about these growth functions before we move on to decay? Okay, remember that growth is when our b value is greater than 1. Okay, we can see that our b value, our base for our exponent in all these, is a bigger number than 1. I'm going to flip this over to decay. Okay, so we're on the back. So this is decay. And our b values are less than 1 for decay. All right, so in all these, our b value is 1/3. 1/3 is a number smaller than 1, so we do indeed have decay. All right, and it's really honestly the same exact process. So for finding our y-intercept, we let x be 0. So y equals 1/3 to the 0 power. Okay, which means, so this was 1, which means that our x-intercept is at 0, 1. So my y-intercept is at 0, 1. I'm going to highlight that down here. Oops, you can't see. Okay, then we have our horizontal asymptote. We add 0 onto the end of this to show it. And our horizontal asymptote is just y equals 0. Okay, so it should be this axis right here. The x-intercept, we should have none because there's no value that is going to make of 1/3 raised to a power that's going to make it 0. This is not possible. So this does not exist. All right, this does not work. And if I stick in a bunch of values, -2, -1, 1, and 2, then I'll get 9, 3, 1/3, and 1/9. So at -2, I have 9. At -1, I have 3. At +1, I have 1/3. And at +2, I have 1/9. So my function is going down like this. So do you guys see the difference between decay and growth? With growth, as we move from right to left, we went up. With decay, we're going down. Okay, what questions do you guys have about that first graph? Okay, I'm going to stop there. I'm going to extend. Honestly, these deadlines were pretty far out anyways. You shouldn't have to worry too much about getting everything done tonight, but I do want to talk about the around the world. So the around the world sheet looks like this. You don't have to use this sheet, but do make sure that you write out your equation. Circle whether the question asks for final amount or time, and write your answer. There should be, oh, do I not have this here? Oh, I do. Okay. So there are several documents on Canvas. The very first one just has the questions only, and it has them both in English and in Spanish. So you can just, I don't care about the fact that it's an around the world today. I don't care if you do number 1 and then you have to try to find the corresponding answer. Let me zoom out. I'm happy for you guys to just do them like 1, 2, 3, 4. Okay. If you want to check your answers, let me show you the page. So on Canvas, we go to our around the world for exponential growth and decay. Okay. So if you look at this file right here, it has the correct question number. Well, I think the correct question numbers are also on the English-Spanish version. So that's this one. Come on, here it is. But if you want to check your answers, what you can do is you can do number 1 and then look through here and see if you find your answer at the top of a card. If you do not find your answer, then you have done the problem wrong, okay? There are 2 things that I have not mentioned yet that I do need to mention. So let me switch back to my document camera, or at least put it as half the screen. So if you have something that says compounded continuously, okay, the base, let me zoom in. Our base is going to be E. It's a number, it's like 2.17. Instead of 1 plus or minus our rate, which is our B value. Okay, so if it says compounded continuously, or if it's talking about, let me find an example. Not that one. It's also with population growth. Here we go. So in this problem, it's talking about the population growth